Okay. Alrighty, right. So this week we are going to tackle and address some really interesting concepts that will help us build a house. Okay, that's going to be our sole focus this week, is the construction of a piece of geometry. But first, a couple questions to get answered. Indigo asked this question in an email this week, and I intentionally did not reply. Many apologies, Indigo, because I wanted to share this information with the entirety of class. Many of you guys noticed that while you guys were working on your bike, I was working on a couple things while I was helping you guys out, and I was doing some renders, okay? And if this ever happens to you, where your render turns out much, much darker, okay? So maybe what you see here, okay, or let me give you a more representative look here, okay? What you see here inside the preview window is different than what is actually rendered. It has everything to do with the color profile and the color management that the motor rendering engine is performing on the rendered image itself. And specifically, what this is called and what you should be looking for is this LUT area, the lookup table. And this defines the color profile that's going to be assigned to your image. Now, what we want to work with is the sRGB lookup table, the sRGB color profile, because we're working and rendering images that are designed to go on these computer monitors, okay? So we want to use the color space of this monitor to render with, okay? Well, there's not CMYK because we're not ink-based artists, okay? However, if you look at the number of LUTs that are in there, there are most of the LUTs that you'd expect to see in the television and feature film world. Now, if I was making a series of renders that I wanted to go on this television here, I would render and save all of my information in Rec 709, which is the default and the standard color space of all televisions, okay? We work in different color environments. So what happens from time to time is that this lookup table gets turned off on accident, and sometimes it's not a fault of yours. Sometimes it's just folks before you coming in and poking around and messing with stuff. Now watch what happens to my rendered image with the, right now it's using the sRGB lookup table, and watch what happens when I change it to none. It's really dark, really contrasty, okay? So if this ever happens to you, before you save your image, just return to the render window and just change your lookup table, your color profile back to sRGB, and this is what you're going to be getting. In addition, this also is in play here inside the preview window. If you look very carefully, we're previewing the sRGB lookup table onto the rendered image. However, we can turn that off and get something really contrasty, okay? Or we can use the raw color space, which has every single color value baked into the pixels. It's pretty cool. If you want more information on the power and the purpose of all these color profiles, one of the lovely developers down at the Foundry did an excellent video that you can easily find on YouTube about color profiles inside of the motor rendering engine. A simple Google search will yield that very, very quickly. I do recommend it for your required reading, as they say. So if that ever happens, just make sure you're using the sRGB lookup table. That's the color space that we're going to be designing and working and building all of our renders to inside of here. All right, let's get on out of here, as they say. Start doing some modeling. Now, during our lab today, we spent some time creating a bicycle. And a lot of you guys were kind of interfacing with some interesting challenges, working and and creating certain parts of the bicycle. Let me show you a really, really great suggestion and series of ideas that will help you create, let's say, the handlebars, for example. Okay. Now, what basic shape is the handlebar? It's a cylinder, right? However, and let's just do this real fast. Let me just jump back over into D2L, canvas. That's a habit, sorry. And I want to put that picture that we were using as a backdrop item. There we go. Let's change its projection type to right. Wonderful. Okay, so let's do this one. Okay, so there's our handlebar. However, our handlebar curves in two different areas at the exact same time. If you look at the profile that we're creating, we have a nice kind of C shape here. If you look at the image down here, it's actually two different bends. Okay. Now, the bend tool is a great tool to help us very quickly make complex shapes like this. I think in every situation, the more we think like the person who's actually responsible for building something like this, the easier it is for us as digital modelers to kind of recreate that entire production practice. So imagine that you are a craftsperson and you're building a pair of handlebars. How would you actually make the handlebars? Get a huge tube, right? And they actually have pipe bending machines that will allow you to bend a straight piece of tube stock to very specific angles, right? We want to do the exact same thing. And for us, inside of Modo, the bend tool is going to allow us to do that. So let's kind of replicate that idea real fast. I'm going to create a long cylinder. Put my sides to 16, so it's just a kind of a good resolution. There we go. Let me just extrude this out. There we go. So there's my long pipe. Okay. Now I've got to start going in and slicing up my pipe to establish kind of zones. These zones, in my imagination, define the beginning of the bend and the end of the bend. Because the bend tool wants to go in and very specifically deform a controlled understanding, or a controlled number of polygons, excuse me. So let's do this. I'm just going to look at my scene from the top, and then using the slice tool, let's just pretend that's the start of my bend. And the first thing that I need to do, looking at our reference again, is let's see. Yeah, it goes straight. Or does it go straight? Let's see. Yes, it goes this way, and then it bends to the front, and then it bends backwards. Okay. So there's my pipe. Let's get everything oriented here. Yeah, so I got to bend it forward and then down, right? You know what may be easiest to do here? Let's do this. I want to rotate this thing 90 degrees. That way, when we're looking at it in perspective, we can kind of get everything to match, okay? Or kind of match. So here's the shape. It goes forward, then it goes that way, okay? All right. So this is going to be the center of my handlebar. So I need to initially begin and bend going forward now. So let's do this. Once again, I'm just going to slice. So this is going to be the area that we bend. Okay. This stuff in here is going to stay static. We want to still keep this perfectly straight. But these are the loops of polygons, or the rows of polygons that we want to bend. I've selected them all using the loop slice tool, and check it out. Now what we can do is that we can go over to our deformation collection of tools and choose bend. Okay? Now the bend tool requires us to go in and initially click to define the beginning of our bend. Okay? So wherever we have that little cross is the beginning of our bend, and this little cube guy is going to represent where we want our bend to finish. So I want to place that kind of right there. Awesome. Okay? And then, of course, this shape in here, or this thing in here, will allow us to do that. Now, what's my critical problem here? Yeah, I don't have everything selected, so I was getting kind of a funky result. So let's grab everything. Fire off the bend tool once again. Okay? And bend forward. Although that doesn't look too hot, does it? Not at all, right? We've lost its entire shape. Look at the envelope of the polygons. It's completely collapsed. This looks like garbage, okay? In order to get a higher quality bend in here and to retain the shape, what do we need? Extra edges. You got it. And the loop slice command is going to give us those pretty quickly. So let's just hit the undo key a handful of times. And I'm going to loop slice. Let's just do a count of 5. And if I hit the uniform button, I ensure that they're going to be evenly spaced, which is what I want. And now, check it out. I can do the bend one more time. Bloop. Awesome. And get a much more consistent shape. So there it is. I've done the bend forward. That's looking pretty good. All right, now we have one more that we need to do. Start a bend, end a bend, right? Let's loop slice that one more time, just like we did. And all of this jazz, or actually it probably should be a much larger, yeah, go ahead. Yes, Alt-C is their shortcut for the loop slice command. Alt-C, and I want to put this to 10 now. Let's try bending it again. Now, I've learned with the bend tool that it's best to use it in the orthographic views. And the orthographic view that you need to choose should be parallel to the plane that you want to bend this along. Because watch what happens. I'm looking at my scene from the top. Watch what happens when I put my tool handle in there. This little disc represents the plane that you're going to bend this shape along. And right now, I can bend it like this, which isn't the way I want to bend it, right? I want to bend it down. Hit the undo key a couple times here, and let's look at my shape from the front. Here we go. And now we can bend with a little bit more accuracy. I want to bend from there to there. 180 degrees this time, or negative 180. And there she goes. It's a good-looking handlebar. It bends forward, and then it bends back. Okay? Pretty cool, huh? The bend tool is extraordinarily powerful. It allows us to take simple shapes like a cylinder, or any shape for that matter, and to deform it into the final resting pose, which is what we're after. Okay? Easily and quickly and controllably, too. All right. Let's jump back over to D2L. Let's jump back over to Canvas real fast and take a look at what we're going to be doing for this week's homework assignment. Your homework this week is to build a house. Okay? Now, you get to choose what house you want to make. We're going to focus exclusively this week on the geometry of our house and use some of these student project examples down at the bottom here to give you a target and an understanding of which direction you're going in. Now, it's your job to figure out what house you want to build. It can be any house that you want. But we're trying to be as accurate and as detailed as we can. Now, can anyone figure out the first two homes there? Yeah, so we got a hobbit hole on the, and then, yes, and then the Simpsons house in the middle, which I find extraordinarily entertaining, right? Yeah.
Do you want us to just do the outside of the house, or do you do the interior?
Just the outside. The interior is an entirely different ballgame, okay? So we're going to focus exclusively on the outside of our house. You're going to have to do some research on this, okay? This is not a box with a roof on it, okay? We need to add compelling details, exterior details, like windows and doors. And look at the Simpsons house. There's a garage door, a front door, windows. Compelling detail that allows us to kind of suspend disbelief. The more the more details that we can build with geometry, the more realistic it's going to feel, okay? Now, there's some ideas and some techniques that we can and should look to use and employ in here to get to this end result a lot faster. It's not about working hard, it's about working smart. So let's jump back over into Modo real fast and look at some extensions to some existing tools that we've already covered that are specifically built for the architectural visualization world. All right, let me turn my grid on here real fast so you guys can see what I'm doing. All right, so there's the origin of my scene. And what I need to do in here is start going in and flushing out the base shape for our house. Now, if you place yourself in the mindset of the person that's building a house, where's a good place to begin? The foundation, right? I like that. Let's pretend that the grid is going to be our foundation, right? What about creating the floor plan? A rough understanding of the exterior walls, okay? Do you have a comment, Moniz, or no? Let's start with building the outside walls. And if you're looking at schematics or a blueprint of a house, you're going to see very quickly the footprint of your house. And then the other drawings, the elevations, will give you a good understanding of the pitch of the roof and the shape of the roof. We're going to start with the walls, and then we'll go to the roof. If we start with the walls, we'll have a nice foundation, no pun intended, that will allow us to very, very quickly and easily add a roof. Okay? Let me show you how we can make a floor plan quickly inside of Modo. Now, I'm going to look at my scene from the top. It's a good practice to jump into the top or an orthographic view when doing this. And, I really don't know what, I want to make up a shape, okay? I'm going to get creative here a little bit. And I want to create a custom floor plan. Now, believe it or not, actually, let me rephrase this. What's an easy way for us to create a custom polygonal shape here inside of Modo? The pen tool, okay? The pen tool is pretty great. Let's check it out. Of course, naturally, our pen tool behaves radically different from the pen tool that you'd see inside of other Adobe apps. And of course, you can find our pen tool right here. Now, the pen tool is a power tool for us. Now, when creating custom n-gons, it's a kind of a one-trick pony. But once we start extending and adding some other options into the mix here, the pen tool takes on a whole new light. Let me show you what I'm talking about. This is how we've been using the pen tool up until now. We've been able to click and add some control points into the mix and create a custom polygonal shape, which is neat. That's fun, okay? But what if I wanted to go in and very quickly craft a floor plan? If we turn on some additions to the pen tool, we can very easily get what we're after without too much fuss and fuss, okay? In addition, we're all about accuracy too, right? Now that we're working inside the world of architectural visualization, we need to start playing and understanding the role of scale inside of our models. Up until now, scale has been something that we really haven't had to worry too much about. But now that we're building something that should match real-world dimensions, we should try as hard as we can to mirror and replicate those real-world dimensions in Modo, okay? Doors are our standard size. Wall thicknesses are our standard size. Our building codes define how each one of these elements should look, and we should strive as much as we can to include that level of details in the models that we're creating. Walls just shouldn't be thick, right? They should be a defined thickness. Now, does anyone know off the top of their head how thick an exterior wall is? 10. It's 10 inches thick. So that's about this big. Okay? Think about it. An exterior wall. That wall, if it's up to current building codes, which I really hope that it is. Of course, the banging sound coming from our ceiling concerns me greatly about the accuracy of this building to code. Anyways, so 10 inches, that's about like this big, right? This big. It's not that much, in all honesty. Interior walls are 6 inches. So this is why we can hear every single thing that's being said on the other side of that wall, right? Because there's no insulation. There is sheetrock, plywood, stud, plywood, sheetrock, right? And a couple layers of paint. 6 inches, that's about this big in between, in the wall itself. It's not that big. So we want to model with those dimensions in hand as much as we can. Believe it or not, the pen tool is more than meets the eye. It's a transformer. If you fire off the pen tool, and before we start clicking, let's add some additional options into the mix. The developers down at the Foundry have done us a solid, and they've added something inside of the pen tool that I find just absolutely wonderful. It's called wall mode. Check it out. If we turn on wall mode, let's just do enter for the time being, it allows us to create an offset amount, a thickness, if you will. Okay? Now, we're going to do an exterior wall, so let's just do 10 inches. Okay? And one quote like that, or that's not a quote. That is a, what is that? No, it is a quote. I'm double guessing myself here. One quote is going to be inches, and then an apostrophe like that is going to be feet. Okay? So one quote is 10 inches, or 254 millimeters. And now watch what happens when I start clicking. We'll close it too. It creates a quad strip for us. That's exactly 10 inches in size. Okay? Now, while the tool is still live, we're free to go in and change all these dimensions and continue crafting this. Maybe we're making an interior wall, or we understand pretty directly what that defined dimension is. There it is. There's 6 inches. Now, I know precisely that the thickness of the wall from that control point right there to its outside edge is exactly 6 inches, and it's consistent across the entirety of the shape. That's pretty great. This is the type of level of detail that we're going to need to go in for architectural models. Okay? The wall modes are kind of fun to play around with. Carefully, the wall mode is set to enter, and the control points are going to be on the inside of. Figure out at where, if you're tracing a schematic, understand where you're putting your points, and then you can grow your walls from either the in or the out. What would you think both sides is going to do? We put the control point in the middle, and now we have 6 inches going into either side. Yeah, Elliot, question. Yeah, so there's this close command right there, and that's going to close the loop, close the curve. All right, I want to put mine back to inner. That's the one I like to work with. And if you look very carefully here, I've done a mediocre job at best in establishing the floor plan, okay? I have what could be described very quickly as the footprint, but if I was an architect, I would be going crazy right now because none of my walls are straight. Last time I checked, having like 90-degree corners on walls is kind of a good idea. Unless we're in the art building, right? Have you guys gone over to the art building? All the walls are like a weird angle, right? Kind of looks like the building's falling down, but it's modern, okay? No.
That's how you get to code, huh?
Yeah. I would love to see, like, in my mind, the dude that came up, or just the person that came up with modern, like the modern style, just couldn't draw. Like, he or she was trying their best to make a straight line, and everything came out of, like, angles, and someone was like, there's a masterpiece! That's it! Anyways, okay.
The French word for rustic is lazy.
I had heard that before. That's wonderful. Okay. Well, I want to be a little bit more OCD, and I want to have straight lines, okay? I want to have all of my corners be like 90 degrees to each other. And I want to start going in and fleshing out a floor plan that is something that we could actually build from, okay? In order for us to do this, we need to employ our snapping system. And you're going to see me use the snapping system a lot. I mean a lot over the next 40 minutes or so. Because the snapping system, when employed and used correctly, is magical, okay? It is wonderful, okay? So the snapping system can be activated up here at the top of the screen. It's a global control, okay? Once it's enabled and turned on, it's literally going to influence every single tool. It's a global operator inside the world of Modo. We enable it by hitting the button or by hitting the X key. X is an X-ray on our keyboard. Check it out. Let me hit the X key real fast. And you can see that, boop, now it's on, now it's off. Now it's on, now it's off. Now when it's on, look over in your, oops. Here we go. Now when it's on, we have a new portion inside of our tool options, this thing. This is our snapping palette, and this will determine what we're going to snap to. Okay? Now we get to access all of our snap options in this little popover, okay? Or we can go to that button at the top of the screen and hold down the option key and click on it and get that exact same popover. I personally like going up here because usually this is where I'm hanging out with my mouse. So if you look carefully down here, these are all the different things that we can snap to, and this is one of the reasons I love working inside of Modo, okay? In other apps, you can only snap to the grid or to an existing point. But look at all the different things that we can snap to, including the center of a polygon and the center of an edge. This is good stuff, man, okay? Now, what I want to enable in this particular situation is the ability to snap to right angles and, of course, straight lines as well. Check this out. Let's turn this on. I'm going to turn off vertex snapping for the time being. Straight line and a right angle. We'll even do world axis snap too. And let's get rid of this and return to, that's fine, return to our wall mode. And now, of course, the first one I lay down isn't going to do anything, but watch what happens when I put the second one down. Bloop. See how it just snaps, okay? That's that straight line snap coming in. Oh, yeah. When I zoom in and it goes crazy, okay? There we go. Oops. Yeah, good stuff. Now, it's hard for me to do it. Let's see if I can. Oh, I am a kung fu with my mouse and scrolling keys, okay? You see that little purple square showing up in the corner there? Go back to 10th grade geometry. What does that mean? It means it's a right angle. So now we know with grand accuracy that that corner is exactly 90 degrees, between the different surfaces, which is pretty neat, okay? Let's do another one in here. So we can do something like this. And now, as you can see, I can very, very quickly flush out some really cool shapes. And I'm going to leave this kind of at an angle over there. That's a good floor plan, okay? I'm going to drop the tool, then turn off my snapping engine, okay? Don't forget to enable and disable your snap, okay? This is a global tool. This is going to affect your move tool and your rotate tool and the scale tool and the bend tool and the loop slice tool. It's literally going to affect everything, so be careful with it. Turn it on, use it, and then turn it off. All right. Let's keep cruising here for a second, okay? Yeah, go ahead. So the question is, what if you're doing an interior and there's a T-shaped wall? Then we have to employ some snapping, or some slicing, excuse me. Now, the cool thing about this, right, is that maybe now, let's do this. Let's put this back to 10 inches. Turn my snap system on, hit the X key, excuse me, I'm getting sloppy all of a sudden. Let me recreate my little thing here with proper dimensions, because it's going to drive me crazy if it's not proper dimensions. Okay, so this is going to be my little shack. Okay, it's not very big. Here, let's make it a little bit bigger, because it's kind of super tiny. There we go. Okay, so what if you want to do like an inside wall? Okay, well, once again, we can go back to the snapping or the pen tool. Let's put this to 6 inches. I'm not going to do close, or I'm not going to enable close. There we go. Now, if I had my vertex snapping enabled, then, check it out, I can snap to, the straight line snaps overriding it, but that's okay, and just get it close. I'm just trying to get it close, that's it, okay? Because then I can use, come on, fingers, there we go. Okay, because then I can use my slicing system to very quickly get what I'm after, right? Because now I'm in full-blown slice mode, and I'm just going to go fast here. If I have, check it out, I got my vertex snap going on, okay? Turn off all those other ones. And the slice tool will now use, at its core, the existing verts inside of my scene to slice to and from. And if I have infinite turned on, my slicing plane will extend past the vert, okay? Oops, excuse me. Okay, do it one more time. There we go, and I've sliced that in just quite beautifully. Same with this one. There we go. One last one. And now I'm in bridge mode. Bridge them together. Bridge them together. Don't need those because they're not doing anything for us, and we're done. Okay. Pretty cool, huh? Pretty cool. So now that we have the basic floor plan of our house kind of in tow here, let's be good stewards of our scene, okay? I want to disable my snap system just temporarily, and let's center this, okay, around the ZX plane. Now, I don't want to center all. The ZX is what I want, okay? So I want to keep that shape on the floor. And now what's next? We've made our floor plan. What's next? Say again? Adding dimensions. We need to raise the walls up and start growing it vertically. Now, the cool thing about working inside of Modo is that 100% of their tools kind of understand the importance of real-world scale values. So we can easily and quickly go in and start raising the roof a little bit, okay? How big is a wall? Could be. Yeah, I think that's a good place to begin. You know, have you ever been in a house that's got like 8-foot ceilings? It's a little claustrophobic, right? 8's kind of the lowest you'll see in most ceilings. I'm happy to have a house where my master bedroom is 10-foot ceilings, which is kind of nice. Some people even have like 12-foot ceilings. The ceilings in this classroom are like 25 feet. And I know this because I have a 3D model of this room that I made a while ago, and I measured it. But point being is that we need to know and understand what those dimensions are. Because check it out. How am I going to raise the walls here? What tool will allow me to do this quickly? Extrude. Yeah, bevel or extrude will do the job. Let me show you an important distinction. Copy paste, or not copy paste. Copy paste. I did it too fast. Okay. Now check it out. I want to extrude up this one, and the other guy I'm going to bevel because it's important for you guys to see the difference between the two tools. So let's just extrude this one. Now, when I apply the tool, now I can go over in here and say I want this to be 10 feet. Okay? And now I know beyond any reasonable doubt that what I've created here are walls that are 10 feet high. I have the foundation for a ceiling height. Okay? Let's do the exact same thing on this other floor plan. But this time we're going to run the bevel. And we get the exact same level of accuracy in the shift value. So I can put 10 feet in there. And we get the exact same thing. We look at it from the front, it's identical. But what's different about it? The bottom. Yeah, good. I'm glad that you guys zeroed in on that. Okay. The bottoms are what's different. This one was using the extrude tool. This one using the bevel tool. The extrude tool is always going to cap the bottom of our polygons, and the bevel tool is never going to do that. Just understand that difference, because in certain situations, having polygons on the bottom side of your wall may help you quickly get to your end results. Okay. Now, for me, what we're going to be doing in here, it really doesn't matter. So I'm happy. I'll delete this one and just work with the one that's beveled in. Okay. So there we go. Now I have some walls that are exactly the height and the dimension that I want, that I'm after. What's next? How about some windows and doors, right? Windows and doors are a good thing. Now, if you take a look around this room, take a look at the windows over there for my office, okay? Are those two windows the exact same size? Yeah, I'd say reasonably, yeah, they're the exact same size. Windows and doors often have a uniform size going around a house. If the curtains were open, if we looked at those windows right there, they'd be the exact same size. The proportions would be pretty uniform going across their height and width. We need to try to recreate that sense of dimensionality throughout all the windows and doors in our house, okay? So how are we going to do this? How are we going to realistically and quickly get, maybe half a dozen windows in here that are the exact same size? Okay? We need to create some openings first, right? Huh? It's an interesting thought. Interesting thought.
Like Boolean?
Yeah, Booleans are a good way of working. Now, what people often kind of land when they're starting to think through this process is they go, what if I can loop slice, right? And loop slice is a good place to begin. I can loop slice this outside bit. Let's put this down to 1, because then I can go in and define the tops and the bottoms. Okay, there we go. So this is going to be the top edge of my windows and the bottom edge of my windows. I can make that pretty uniform going around the entirety of my house. The problem are the vertical sides. How can I create a consistent size of all my windows going around my house? And this is where the problems come in, because I could go in, I can loop slice again. So, okay, that's going to be, the outside edge over there, all right? Maybe that's the outside edge of another window, but, oh, man, look what happened. Because of the loop and because of that mitered corner over there, this inside edge is at an angle, so that's just not going to work, okay? We're not going to get the result that we're after. Thus enter the role of Booleans. Now, I'm about to open Pandora's box, okay? With great power comes great responsibility. Be careful with Booleans. They can very easily destroy your mesh if you're not aware and watching what it's doing. Booleans allow us to create geometry that can slice and affect other pieces of geometry, okay? So instead of using these planes like the edge slice tool or the slice tool to go in and cut our pieces up, okay, we're going to use existing pieces of geometry to do that job for us. Let me show you what this looks like. The first thing that we need to do is go in and physically create some geometry. Let's be good stewards of our scene here. I'm going to name this mesh item house, okay? And I'm going to create a new mesh item, and I'm going to call these windows, okay? So this is the mesh item that I'm going to place all my windows in. This is a hard requirement, by the way, of the Boolean system. We need to separate the geometry that we're keeping from the geometry that we're cutting with into separate mesh items. Yeah, question? When you extrude it, it doesn't bring up walls. Did you select all the polygons? Okay. Jesse, what computer number are you? 21. Let's take a look. Here we go. Come on, remote desktop, do your thing. Let me see Jesse's machine. You're in the vertex extrude command, Jesse. Hit the undo key a couple times to get rid of that tool and go back to the basic tool tab. That's the extrude. Shift X is the one that you want to use. Yep. All right. So in order for Booleans to work, we need to physically separate the pieces out into their own mesh item. We have the one mesh item that is the one that we're going to keep, if you will. And the other mesh item is its sole function and responsibility is to cut. Okay? So let's do it real fast. Let's make a window, and I'm just going to use the cube tool to kind of flush this out. Now, how big is my window going to be? What do you think is a good starting point for the size of my window? What's the width?
Well, how big's your wall?
It's 10 feet high. Yeah, by, I don't know, by 20? I don't know. What's a good starting point for a window, you think? How big should a window be? Like about shoulder width apart. That's a good place to begin. So maybe about 30 inches this way, and maybe 48 inches tall. That's a good place to begin. The cool thing about working inside of Modo is that we always have access to real units, the real world units. So I can very quickly go in and say this is going to be 30 inches wide by, by 48 inches tall. There we go. Now the Z depth in this particular, this needs to be 30 inches since it's turned. There we go. Wait, that is not right. Which way am I facing here? I am facing the negative Z. So I had it right the first time. Goodness. Well, let's try that again, shall we, folks? Okay. So I want it to be this way, size Z, 30 inches, and 48 inches. There we go. Now this depth I don't care so much about. Okay? In order for us to get Booleans to work correctly, we need to create geometry that's of the size that we want, but we have to make sure that geometry crosses through the mesh. Okay? See how I've crossed it all the way through? It needs to go through the outside wall and the inside wall. This is another hard requirement of working with Booleans. It's got to go all the way through, okay? And now that we have these, check it out. We can do a whole lot with them. Because this is just geometry. Now I have a bathroom over here in my imagination. It's going to be, no, it's not going to be a bathroom. It's going to be a snack shack on the inside. Okay, anyways. How can I very quickly, maybe I want to have 3 windows along this wall. How can I do that? Clone tool, yeah, the clone tools that we went over last week will allow me to make a lot of copies very quickly. So duplicate, clone. I don't want 4. There we go. I love it. Good. Now it's figuring out that middle one for me. Rock and roll. So let's pretend that this is the back. Let's see. Yeah, this is going to be my back patio over here next to my snack shack. Okay? This is my side of my house. Huh? Separate mesh. Yeah, that's a hard requirement. So I'm going to use one of these. I'm going to copy, paste, and rotate the duplicate just 90 degrees and put it into position because I want to have, this is going to be my front door over here. And I want to have a whole bunch of windows in the front. And once again, I'll just run the clone. Okay? I want everyone to see that I'm eating my snacks in Pat's Snack Shack. Okay, there we go. This is where the front door is going to be. Of course, I need to have a window over here in the back, and of course, a sliding glass door as well. Now, for that one, I'm just going to go in and kind of freehand sketch. It's going to be a big daddy guy. Okay, something like that. Maybe a little too big. All right. But now I have a little bit of a problem. That's going to be massive window. Okay, there we go. All right, so I have a little bit of a problem on my hands. On my windows layer, I've established the height, the top of all my windows with these polygons, and of course the bottom of all my polygons on these. I want this one to be the exact same height, okay? How am I going to do that? Quickly. I want that top polygon on my big bay window on the back of my house to be in the exact same space within the y-axis as my other ones, and same with the bottom. Is there a way that I can very quickly ensure that all this is getting kind of, put together correctly? Snapping. It's all about snapping, right? It's the key to the kingdom. So you're going to be amazed how accurate your models get when we start snapping. Okay, let me do it real fast here. I'm looking at my scene from the front, and I'm going to grab that top window, or that top part of the polygon, which is going to represent the top part of my window. I'm going to turn on my snapping engine, and most importantly, I'm going to enable my vertex snapping. Now check out this. If I fire off the move tool, I'm going to grab the Y indicator handle. I'm going to put it on the vert that I want to snap to. See how it snaps? Whoop. Go. I love it. It's good stuff. Now this works really well if you grab the handle first, and then you can put your cursor on what you want to snap to. And within a couple seconds, I know that the height of this window over here is identical to the height of all the other windows in my house. I've created a uniform sense of all my windows. Looking good. Now, if I wanted to make a change, I can make a change to all of them exclusively, and things are starting to rock and roll here. I like it very much. All right, let's pretend just for giggles that this is it. I'm happy with what I've created, and I want to start going in and punching in some holes in my walls, okay? This starts the Boolean process. Now, in order for us to begin crafting and creating these little holes in our walls with Booleans, we need to follow a defined selection order, and this es muy importante, as they say, okay? Because if this isn't selected correctly, it's just not going to work, okay? The first thing that we have to have selected is our house, the thing that we want to keep. And the one that's unselected, or in the background of the Modo scene, is going to be the mesh object that's going to be responsible for slicing and cutting up the walls of our house, okay? So I'm going to go in and select the house, because this is the thing that I want to influence, and I want to have the windows be the influencer. In the Modo world, the mesh item that is selected is in the foreground, and everything that's unselected is in the background. Now, if you have multiple meshes going inside of your scene, anything that's visible, that's unselected, is going to be evaluated by the Boolean engine. Let me show you specifically what I'm talking about. So what if I had a third mesh item in here? Oops. It's a big sphere. Okay, there it is. There's my sphere. Maybe I want to have, there we go. Maybe a little too big. I may have overexerted myself. Cap. Maybe I have a cool spherical circular window going on here. Okay. Now, with that item on and evaluated inside of my scene, okay, what are the two mesh items that are going to be slicing and cutting up my mesh? Windows and spheres. Anything that's visible is going to act as a slicer, okay, and it's going to be evaluated by the Boolean tools. Yeah, go ahead. If they're just wireframe, it's just a viewport property. I actually like the wireframes a little bit more directly. If you hit the O key and bring open your viewport properties, the inactive meshes section has been changed, and the shading style is at default. I'm going to put mine to wireframe because I actually like that a little bit better. I can very easily see what's selected and what's not selected. Yeah, go ahead.
So you said anything that's visible. So like if the little eye, you turn it off, it won't get sliced.
Yeah, absolutely.
Little eye in the top right corner.
This right here, okay? And I'm going to leave the sphere on just to kind of illustrate this, and then we'll go back in and turn it off here in a second, okay? So all we have to do is ensure that the layer that we want to slice is selected, and everything else is unselected. To do the actual Boolean tool itself, we're going to go to the top of the screen where it says Geometry, and then you're going to find all of our Boolean tools way down here at the bottom. And there are three different tools. We have Axis Drill, Solid Drill, and Boolean. Now, I'm a real big fan of Solid Drill. That's my fave, okay? I'm going to let you guys explore what Axis Drill and Boolean do. The reason I love Solid Drill so much is that it puts me in the driver's seat. it ensures that I get to make the next decision. I always want to be in control of my model, and solid drill gives me the most control. Let's look at it real fast. We'll do the solid drill tool. You're going to get this cool little popover. Looks something like this. And the first thing that we're going to be presented with is the operation. Which type of solid drill do we want to do? And what we want to do is slice. Okay? The slice command just gives us the most control. Okay? It allows us to dictate and determine what this next step is going to be. I want to choose slice. And look what the driver mesh is going to be, background. Now once I hit OK here, bloop, look at my walls. What happened to my walls? Can you guys see it? Yeah, they've been sliced. If I turn off my sphere, if I turn off my windows, you can see what the Boolean tool has done for us. It's gone in and sliced both the inside and the outside of my walls. And here's my cool little circular window. Okay? Yeah, go ahead.
I tried the Boolean and just few cubes. And for some reason it had this weird extra edge.
It's always going to add that extra edge, and that's not a problem for us because it needs to figure out how to solve this surface by connecting a vert from what we just sliced to an existing edge or vert that's already on that shape. So that's normal. I'm going to turn off my sphere because I don't want just one. That's fine. Let's do it one more time. Boolean solid drill. And then I'm going to choose the slice operation and hit OK. Turn off my windows because we don't need them anymore. Yeah, and there's that extra edge that I got on mine right there. Kind of that diagonal guy. It's fine for the time being.
Wait, so the house is invisible? The eye is the only thing that you... Okay.
Yeah. I turned it off on accident, but the house is visible at the moment. Okay, so what do we do next? We have some windows. What's the next step? Yeah, we can pop them out. And this is why that slice command is so powerful, because I get to control what we do next. Okay? So, for example, I can go in, just grab maybe that side. Here's a great trick, by the way. Grab that side, grab that side, bridge them. Bloop. We now have a window frame. Okay? That side and that side, bridge them. Bloop. We now have a window frame.
You press delete on both sides.
Let's do it. Now we have a hole. Okay? When we bridge them, and you can still bridge them just by selecting them like this. It just saves you an extra step, what I'm just doing. Just go around, bridge them. Okay? Now, I'm going to show you one quick thing because we want to try to, as best we can, create some compelling detail in here. And imagine we're the framers of the house. We just framed out that window. Okay? What do we need to add now? Well, doors are separate, right? But inside the window itself, what's needed? The window itself, right? The window itself. And windows, if you've ever worked with windows, there's a frame that the window sits in. And then the window, the actual piece of glass, is sandwiched between two interior pieces. Let me show you how we can build that real fast, okay? Believe it or not, it goes pretty fast, and it is extraordinarily easy to make all this stuff, okay? I think I'm going to do this. I'm going to grab that loop, and the bevel tool is going to be our jam, okay? Because the bevel tool allows us to go in and start making some pieces. And I can even get super accurate if I wanted. Like maybe I have that one be 1 inch, okay? Yeah, then I can do a small inset. Bring that in 0.5 inches, okay? And then do another bevel up of 1 inch, okay? There's the beginning of a pretty decent window frame. Now what we need to add is that next bit. And believe it or not, loop slice with a count of 2 will allow us to get the structure that we're after. Okay? Now we're talking. Okay? Or you can do this. Also bevel it. Do an inset. That way you can numerically do it. Let's 0.5 inches. Okay? And you can start building up your window frame. Okay? Now I'm running out of time. There's one more thing that I wanted to talk about today before we walked away. And that's our roof, okay? Our roofs are really great opportunities to explore the application of the Boolean tools, okay? The Boolean tools are really powerful, but you've got to be careful with them. If we think about the strategy of using Booleans, we can create some very complex shapes pretty quickly. Now, what basic shape is a roof? Yeah, it's kind of It's a square that's been brought up in the middle. Okay? So let's do this real fast. I think here's how I'm going to choose to build my roof. Roofs aren't very thick, by the way. A lot of people think they're really thick and heavy like that. They're not. They're only a couple inches in thickness, maybe 4 or 5. They're not that big, okay? And here's what I'm going to do. I'm going to try to establish, as best I can, the pitch of the roof first, the rotation, okay? Now, I'm just looking at angle here. I don't care so much about the width of that polygon, or excuse me, the length of that polygon. I'm just trying to look at the angle. Let me turn on the visibility of my grid. There it is. So here's the center line of my house right there. Okay, and that's pretty good. Now I can just slice that. Okay, now if I move that around, it's going to change the pitch, which is not what I want. So instead of slicing it just kind of randomly, what if we enabled maybe some grid snapping? And now my slice tools, once I turn the snapping engine on, now my slice tools will snap to the grid and give me the control that I'm after. Okay, there's the pitch of my roof. Okay, let's do this. While we're here, let's mirror it. I still got my snapping system on. Whoop, there we go. Since I sliced to the origin and then I mirrored at the origin, everything is matched quite perfectly. All right, let's move this into position here real fast. Then we'll get out of here. So there's my roof. Okay. Now, what's wrong with this picture? Yeah, I got the world's best air conditioning going on right here, right? Yeah, it's just, yeah, I got super energy efficient. Your AC is going to be going nonstop in your house, right? You can take advantage of that nice Delta breeze that we get here in Sacramento, right? So we need to raise the exterior walls of our roof to match the pitch of our roof, right? Excuse me, the exterior walls of my house to match the pitch of our roof. Now, if we're smart, maybe we can use that Boolean system once again to help us get where we're going, because I need to very carefully change the walls, okay? A lot of folks, they try to do this. They go, well, I can just raise the walls up, and then maybe I can grab like that edge there and move it up a little bit to match, and that's just, it's never going to look real, and it's going to take a lot of time to take the existing geometry and match it to the pitch of the roof. So let's use Booleans. So I want to grab all of my walls, and I want to move them up past the roof like this. Now don't worry about all this mumbo jumbo. We'll get into that in a second, okay? Oops, looks like I didn't grab. Okay. There we go. Wonderful. All right, looking good. Now we're going to use Booleans to get this slice up my walls. However, let's put that roof in a new mesh item. Command X to cut. I'll create a new mesh item, then paste it in. Just call this roof. There we go. Which one of these mesh items do I have to have selected in order for the Boolean to work correctly? House. You got it, house. We have to select the object that we want to slice. So I want to slice my house, the walls of my house, with my roof. Notice that my roof is the only mesh item that's currently visible. Okay? Now with that in tow, let's do it. Geometry, Boolean, solid drill. We'll leave the operation at slice and hit OK. Check it out. Once we turn off my roof, you can see that I've sliced my walls perfectly to the pitch of the roof. Okay? And now it's just a process of deleting all of the chaff. Boop. Turning my roof back on, and there she blows. Okay? Which is pretty great. Booleans are an excellent, excellent tool for us because it allows us to take existing geometry and it allows us to use existing geometry to influence other pieces of geometry. Okay? The areas that people get stuck is that they have a lot of mesh items turned on, or they're not aware of the intersections of two different objects within inside the scene. Keep in mind, you're using pieces of geometry to slice other pieces of geometry. Okay? Now you have two things that we're striving to complete this week for our homework. Of course, we're going to be building a house, but really the most important part, and the first thing that I would like you guys to do, is your lab assignment. Let's go back into the week 9 section on Canvas and look at your lab, which is going to be some research. Okay, I want you to go out and get comfortable with how a house looks. Okay, everyone thinks they knows what a house looks like, but then you have to build one in 3D, and often the train derails pretty quickly because what we think and what we're actually able to produce are two different things. So let's use, at the foundation of this entire project, research and reference images to lead our decision-making process. Okay, I want you to go out, do some research, look at some pictures of houses, get comfortable with how all of these forms and shapes are put together. The cool thing about making a house is that they're relatively cubic, right? They're pretty planar. Okay, do some reference research, look at houses, and then I'm going to force my hand on this. You're going to turn in the research that you did. Okay, you have to go out and find at least 10 images on the web that you can use as to kind of begin the conversation, your understanding of how houses look, zip them up in a compressed archive, a zip file, and submit it here in Canvas. Yeah, do some research. Start looking at the way houses are put together. When you're choosing which house to build, try to find as much research as you can on that house. If you wanted to build your own house, which I think is a great place to begin, or your apartment complex, or wherever it is that you're staying, maybe a building here on campus, take some pictures of it, right? It really is going to help. Yeah, go ahead.
Okay, so when you're making the roof, and you had one part bent, you cut the middle, and then you had that one part bent. How'd you get the other part perfectly?
I mirrored it.
Okay.
I mirrored it, yeah. Yep. I mirrored it. So do some research, okay? Do some research. Look at the details. Now, don't go crazy with the details. Use the perspective of the student examples as a good gauge of how you're probably going to be rendering this assignment when you're done, okay? Look at this perspective. Your camera is going to be pretty far away from the object, okay? So we don't need to go in and make the subdivision surfaces. We don't need to go put in a bunch of detail. I had one student, this was a couple years ago now, he waved me over to his machine and said, "Pat, look at this door," right? And he had modeled the most beautiful door, right? And specifically the door handle was absolutely beautiful. But it was like a 10,000 polygon door handle, right? It was a lot of detail on this door handle. And he was proud of it, and he did some good work in there, right? And then I asked him, I was like, okay, make a render, right? And he, of course, he put his camera back to this kind of view. And how big was the door handle in the actual shot? Like 2 pixels, right? He spent like 3 hours making something that turned into like 2 pixels in the final render. So keep in mind the level of detail that you're going to have to model to match the distance from the actual object. Don't go in and spend 3 hours on a door handle that's going to show up this big, in the actual render itself, okay? Now, you're just going to be working on the geometry this week, just the geometry, so no textures, no textures. Next week, we're going to spend all of our time looking at textures, and so here's some really great examples of what we're striving to kind of go for. Just geometry, just geometry. Next week, we're going to spend all of our time talking about the Italian texture workflow, because how we texture big objects like a house or an exterior is very different than how we texture a small object like a crate or a wine barrel, okay? Some things that I would like you to include in your house, believe it or not, is some compelling detail. Try to make a small little scene as much as you can, okay? Make a house, a simple landscape. If you want, start adding some detail like trees and bushes and rocks, a fence, put a car in the garage. Whatever you can find online for those other things is fine. You don't have to go model a tree. I wouldn't want you guys to model a tree. It's a waste of time.
I was wondering for the back end, did they actually model those plants or are those brought into?
I believe they modeled the plants. Yeah, those are Josh modeled those. Yep, those are all his plants. Pretty cool, huh? Yeah, some good stuff. The more detail we can create geometrically, the easier it is for our audience to understand what it is that we've created. Sound good? Questions on what we're going to be doing this week? So do the research first. This is the easiest lab assignment you'll have all semester, right? Just go find some pictures, get comfortable with what you're going to build, zip them up into a zipped archive, submit them to the Canvas, you're done. Yeah?
Speaking of the reference, do you have to send it to you on Canvas?
Canvas, yes. I want you to zip up the pictures. You have to do at least 10 of them, right? Zip them up into an archive, submit them to Canvas. That part's done. Go on to modeling.
How do we zip?
You can select all the files inside of your Finder app on the Mac, right-click, and then in the contextual menu that'll pop up, they'll be compress. Same thing for on a Windows machine. It's very, very similar. Other questions, comments? If you want to go back in and look at this whole Boolean system, just make sure you reference the live stream. I was live streaming today, so all the content's online. Sound good? All right, I'll see you guys next week.